Hello everyone, welcome to the channel Amazing Civil Engineering Studies. Here we are with a new video.
In this video, we will go through numerical related to combined footing. Detailing of combined footing. Detailing of steel, both longitudinal and transverse, in a combined footing is similar to that of conventional beam SP34. Detailing requirements of beams and slabs should be followed as appropriate. SP34. SP34, Handbook on Concrete Reinforcement and Detailing. Note you can download this from the link mentioned in Details section. Numerical. Design of combined footing, slab and beam type. Two interior columns A and B carry 700 kN and 1000 kN loads respectively. Column A is 350 mm x 350 mm and column B is 400 mm x 400 mm in section. The center-to-center spacing between columns is 4.6 meter. The soil on which the footing rests is capable of providing resistance of 130 knots per square meter. Design a combined footing by providing a central beam joining the two columns. Use concrete grade M25 and mild steel reinforcement. Draw to a suitable scale the following. The longitudinal sectional elevation. Transverse section at the left face of the heavier column. Plan of the footing. Solution, data FCK equals 25 n/mm2, phi equals 250 n/mm2, FB equals 130 kN/m2, SBC, column A equals 350 mm x 350 mm, column B equals 400 mm x 400 mm, CC spacing of columns equals 4. 6m, PA equals 700 knots and PB equals 1000 knots required, to design combined footing with central beam joining the two columns. Ultimate loads PU. A equals 1.5 x 700 equals 1050 knots, PU. B equals 1.5 x 1000 equals 1500 knots. Proportioning of base size working load carried by column A equals P. A equals 700 knots working load carried by column B equals P. B equals 1000 knots self-weight of footing 10% x, P. A plus P. B equals 170 knots total working load equals 1870 knots required area of footing equals A. F equals total load SBC equals 1870/130 equals 14.38 square meters. Let the width of the footing equals B. F equals 2m required length of footing equals L. F equals A. F B F equals 14.38/2 equals 7.19 m. Provide footing of size 7.2 m x 2 ma. F equals 7.2 x 2 equals 14.4 square meters. For uniform pressure distribution, the CG of the footing should coincide with the CG of column loads. Let x be the distance of CG from the center line of column A, then x equals P B x 4.6 slash P A plus P B equals 1000 x 4.6 slash 1000 plus 700 equals 2.7 m from column A. If the cantilever projection of footing beyond column A is A, then A plus 2.7 equals L. F 2 equals 7.2/2, therefore A equals 0.9 m. Similarly, if the cantilever projection of footing beyond B is B, then B plus 4.6 to 2.7 equals L. F 2 equals 3.6 m. Therefore B equals 3.6, 1.9 equals 1.7 m. The details are shown in figure. Rectangular footing with central beam design of bottom slab. Total ultimate load from columns equals P U equals 1.5, 700 plus 1000 equals 2550 knots. Upward intensity of soil pressure W U equals P/A. F equals 2550/14.4 equals 177 knots per square meter. Design of slab intensity of upward pressure equals W U equals 177 kN/m2. Consider 1 meter width of the slab, B equals 1 m. Load per m run of slab at ultimate equals 177 x 1 equals 177 kN/m. Cantilever projection of the slab, for smaller column, equals 1350/2 equals 825 mm. Maximum ultimate moment equals 177 x 0.8252/2 equals 60.2 knots m. For M25 and Fe 250, Q U max equals 3.71 N/mm2. Required effective depth equals square root 60.2 x 106/3.71 x 1000 equals 128 mm. Since the slab is in contact with the soil, clear cover of 50 mm is assumed. Using 20 mm diameter bars, required total depth equals 128 plus 20 halves plus 50 equals 188 mm. Say 200 mm provided effective depth equals D equals 200-50-20/2 equals 140 mm. To find steel M U BD2 equals 3.073.73 URS M U equals 0.87 F Y A ST DF Y A ST F CK B P T equals 1.7%. A ST equals 2380 mm2. Use Phi 20 mm diameter bar at spacing equals 1000 x 314 2380 equals 131.93 say 130 millimeters cc area provided equals 1000 x 314 130 equals 2415 mm2. Check the depth for one-way shear considerations at D from face. Design shear force equals V U equals 177x 0.825 to 0.140 equals 121 kN. Nominal shear stress equals tau V equals V U BD equals 121000/1000 x 140 equals 0.866 MPa. Permissible shear stress P T equals 100 x 2415 1000 x 140 equals 1.7%. Tau UC equals 0.772 N/mm2. Value of K for 200 mm thick slab equals 1.2. Permissible shear stress equals 1.2 x 0.772 equals 0.926 N/mm2. Tau UC tau V and hence safe the depth may be reduced uniformly to 150 mm at the edges. Check for development length. L dt equals 0.87 x 250, 4x 1.4, equals 39. Equals 39 x 20 equals 780 millimeters. Available length of bar equals 825 equals 800 millimeters. 780 millimeters and hence safe. Transverse reinforcement. Required A ST equals 0.15 BD/100 equals 0.15 x 1000 x 200/100 equals 300 mm2. Using 8 mm bars, spacing equals 1000 x 50/300 equals 160 millimeters. Provide distribution steel of 8 mm at 160 millimeters cc. Design of longitudinal beam. Load from the slab will be transferred to the beam. As the width of the footing is 2 m, the net upward soil pressure per meter length of the beam equals W U equals 177 x2 equals 354 kN/m. Shear force and bending moment V AC equals 354 x 0.9 equals 318.6 kN, V AB equals 1050 to 318.6 equals 731.4 kNv. BD equals 354 x 1.7 equals 601.8 knots, V. BA equals 1500 to 601.8 equals 898.2 knots. Point of zero shear from left end CX 1 equals 1050/354 equals 2.97 m from C or X. 2 equals 7.2 to 2.97 equals 4.23 m from D. Maximum BM occurs at a distance of 4.23 m from DM. UE equals 354 x 4.2322 1500, 4.23 1.7, equals minus 628 kN.m. Bending moment under column A equals m. UA equals 354 x 0.922 equals 143.37 kN.m. Bending moment under column B equals m. UB equals 354 x 1.72 equals 511.5 knots m. Let the point of contraflexure be at a distance x from the center of column A, then m x equals I050 x 354 x plus 0.9 2/2 equals 0. Therefore x equals 0.206 m and 3.92 m from column A, i.e. 0.68 m from B. Depth of beam from BM. The width of beam is kept equal to the maximum width of the column, i.e. 400 mm. Determine the depth of the beam where T-beam action is not available. The beam acts as a rectangular section in the cantilever portion, where the maximum positive moment equals 511.5 kN/m. D equals square root 511.5 x 106/3.73 x 400 equals 586 mm. Provide total depth of 750 mm assuming 2 rows of bars with effective cover of 70 mm. Effective depth provided equals D equals 750 to 70 equals 680 mm, less than 750 mm, and hence no side face steel is needed. Depth of beam from BM. The width of beam is kept equal to the maximum width of the column, i.e. 400 mm. Determine the depth of the beam where T-beam action is not available. The beam acts as a rectangular section in the cantilever portion, where the maximum positive moment equals 511.5 kN/m. D equals square root 511.5 x 106/3.73 x 400 equals 586 millimeters. Provide total depth of 750 millimeters assuming 2 rows of bars with effective cover of 70 millimeters. Effective depth provided equals D equals 750 to 70 equals 680 millimeters, less than 750 millimeters, and hence no side face steel is needed. Check the depth for two-way shear. The heaver column B can punch through the footing only if it shears against the depth of the beam along its two opposite edges, and along the depth of the slab on the remaining two edges. The critical section for two-way shear is taken at distance D/2, i.e. 680/2 mm, from the face of the column. Therefore, the critical section will be taken at a distance half the effective depth of the slab, ds/2, on the other side as shown in Fig. In this case B equals D equals 400 mm, D B equals 680 mm, D S equals 140 mm. Area resisting two-way shear equals 2 bxd B plus D S xd S plus 2 D and D B ds equals 2 400 x 680 plus 140 x 140 plus 2 400 plus 680 140 equals 885,600 mm2. Design shear equals P UD equals column load W U X area at critical section equals 1,577 x B plus D S X D and D B equals 1500-177 x 0.400 plus 0.140 x 0.400 plus 0.680 equals 1377.65 kN. Tau V tongue sticking out UD B O D equals 1377.65 x 1000/885600 equals 1.56 MPa. Shear stress resisted by concrete equals tau UC equals tau UC XK S where tau UC equals 0.25 square root F CK equals 0.25 square root 25 equals 1.25 N/mm2 K S equals 0.5 plus dd equals 0.5 plus 400/400 equals 1.5 less than or equal to 1 hence k s equals 1. Tau UC equals 1x 1.25 equals 1.25 n/mm2 therefore unsafe. Area of steel, cantilever portion BD. Length of cantilever from the face of column equals 1.70.4/2 equals 1.5 m. Ultimate moment at the face of column equals 354x 1.52/2 equals 398.25 kNm. M. Max equals 3.71x 400x 6802 x 10⁻6 equals 686 knots m 398.25 knots m. Therefore section is singly reinforced. M. U. BD2 equals 398.25 x 106/400 x 6802 equals 2.153.73 URSP. T equals 1.114%. A. ST equals 3030 mm2, provide 3π32 mm plus 4π16 mm at bottom face, area provided equals 3217 mm2. L. DT equals 39x32 equals 1248 mm. Curtailment. All bottom bars will be continued up to the end of cantilever. The bottom bars of 332 will be curtailed at a distance d equals 680 mm from the point of contraflexure, lambda equals 680 mm. In the portion B with its distance from the center of support equal to 1360 mm from B. Cantilever portion AC. Length of cantilever from the face of column equals 900-350/2 equals 725 mm. Ultimate moment equals 354 x 0.72522 equals 93 knots. MUBD2 equals 93 x 106/400 x 6802 equals 0.523.73, URSPT equals 0.245%, greater than minimum steel. AST equals 660 mm to provide 416 mm at bottom face, area provided equals 804 mm to continue all 4 bars of 16 mm diameter throughout at bottom. Region of between points of contraflexures. The beam acts as an isolated T-beam. BF equals low B plus 4, plus BW, where LO equals 4.6 minus 0.2060.68 equals 3.714 m equals 3714 millimeters. B equals actual width of flange equals 2000 millimeters. BW equals 400 millimeters. BF equals 3714/. 3714/2000 plus 4, plus 400 equals 1034 mm. MUV equals 0.36 x 25 x 1034 x 200, 680 0.42 x 200, x 10-6. Equals 1109 kN.mu, equals 628 knots m. Therefore x u f m u equals 0.87 f y a st df y a st f ck b f a st equals 4542 mm2. Provide 5 bars of 32 mm and 3 bars of 16 mm. Area provided equals 4021 plus 603 equals 4624 mm2 greater than 4542 mm2. P T equals 100 x 4624 slash 400 x 680 equals 1.7%. Curtailment. Consider that two 32 mm are to be curtailed. No of bars to be continued equals 316 plus 332 giving area equals A ST equals 3016 mm2. Moment of resistance of continuing bars M equals 0.87 x 250 x 3016, 680, 250 x 3016, 25 x 400, x 10⁶ equals 396.6 knots m. Let the theoretical point of curtailment be at a distance x from the free end C, then m UC equals m Therefore minus 354 x 22 plus 1050 x 0.9 equals 396.6 x 2-5.93 x plus 7.58 equals 0. Therefore x equals 4.06 m or 1.86 m from C. Actual point of curtailment equals 4.06 plus 0.68 equals 4.74 m from C or 1.86. 0.68 equals 1.18 m from C. Terminate two Phi 32 mm bars at a distance of 280 mm, equals 1180 900, from the column A and 760 mm, equals 5500 4740, from column B. Remaining bars 3 Phi 32 shall be continued beyond the point of inflection for a distance of 680 mm, i.e. 460 mm from column A and up to the outer face of column B. Remaining bars of 3 Phi 16 continued in the cantilever portion. Design of shear reinforcement portion between column IEAB. In this case, the crack due to diagonal tension will occur at the point of contraflexure because the distance of the point of contraflexure from the column is less than the effective depth d, equals 680 millimeters. I. Maximum shear force at B equals V. Max equals 898.2 knots. Shear at the point of contraflexure equals V UD 898.2 to 354 x 0.68 equals 657.48 knots. Tau V equals 657,000 / 400 x 680 equals 2.42 MPa tau. C max. Area of steel available 3 phi 16 plus 3 phi 32, A. St. Equals 3016 mm2. P. T. Equals 100 x 3016, 400 x 680, equals 1.1%. Tau C equals 0.664 MPa. Tau V Tau C. Design shear reinforcement is required. Using 12 mm diameter 4-legged stirrups. Spacing equals 0.87 x 250 x 4 x 113, 2.42 to 0.664, x 400 equals 139 mm say 120 mm cc. Zone of shear reinforcements between tau V to tau C equals M from support B towards A. 2. Maximum shear force at A equals V. U max equals 731.4 knots. Shear at the point contraflexure equals V. UD equals 731.40.206 x 354 equals 658.5 knots. Tau V equals 658,500 / 400 x 680 equals 2.42 MPa tau. C max. Area of steel available equals 4,624 mm2, P. T. Equals 100 x 4,624, 400 * 680, equals 1.7%. Tau UC equals 0.772 n/mm2. Tau V Tau C. Design shear reinforcement is required. Using 12 mm diameter 4-legged stirrups, spacing equals 0.87 x 250 x 4 x 113, 2.42 to 0.774, x 400 equals 149 mm, say 140 mm cc. Zone of shear reinforcement. From A to B for a distance as shown in figure. For the remaining central portion of 1.88 m, provide minimum shear reinforcement using 12 mm diameter two-legged stirrups at spacing S equals 0.87 x 250 x 2x 113 slash 0.4 x 400 equals 307.2 mm, say 300 mm cc. Cantilever portion BD. Viewmax equals 601.8 knots, VUD equals 601.8-354, 0.400/2 plus 0.680, equals 29,028 knots. Tau V equals 290280/400 x 680, equals 1.067 MPa tau C max. AST equals 3217 mm2 and PT equals 100 x 3217/400 x 680, equals 1.18%. Tau C equals 0.683 n/mm2, Table IS 456-2000. Tau V Tau C and Tau V Tau C 0.4. Provide minimum steel. Using 12 mm diameter two-legged stirrups, spacing equals 0.87 x 250 x 2x 113, 0.4 x 400, equals 307.2 mm, say 300 mm cc. Cantilever portion AC. Minimum shear reinforcement of 12 mm diameters two-legged stirrups at 300 mm cc will be sufficient in the cantilever portions of the beam as the shear is very less. Diagram showing reinforcement detailing of footings.
Thank you for watching.
For now, please subscribe, like, share and do not forget to press bell icon.